Here is a still picture from a Logger Pro analysis of a hover puck that floats across the surface of this particular desk. And we use Logger Pro to identify the positions in equal increments of time, and so in effect it allows us to map out a motion map. You can see the dots are evenly spaced as it moves to the right, which means it has constant velocity. And one of the great things about Logger Pro is that it will automatically plot these positions as time progresses. And so you can see again the linear nature of this constant velocity, the linear nature of the position versus time graph. You can see that I have the same Logger Pro analysis of the hover puck sliding across the table with a constant velocity, and you see again the position versus time graph that comes out with a positive slope that's constant, indicating constant velocity. But I've also been able to use the power of Logger Pro to put a best fit line on this particular graph. And so if you click this button, this R equals button, then it will create a best fit line with the slope calculated for you as well as the intercept. And notice that the slope from Logger Pro actually includes the units of meters per second. A meter is another unit for measurement of distance or displacement or position. And of course the vertical intercept, which we identified as the initial position, is slightly less than 0 because the puck, when I started measuring according to their scale, was a little bit behind the origin. Suppose a car can speed up when it's released, then what would the motion map look like, and what would the position versus time graph look like? Well, I was able to find a movie which I showed in class of such a car, and you can tell that the dots are very close together, but as it moves across the floor the dots become further and further apart. And so what happens is the position versus time graph actually starts to slowly get steeper, and so we observe that the position versus time graph is curvy as opposed to linear. And since it's getting steeper, then that means it's getting faster. We could also get an speeding up motion by taking the surface that the hover puck was moving across and elevating it and making it a ramp. And so it's very difficult to see here, but the dots created by the Logger Pro analysis are getting slightly further apart as the hover puck goes down the ramp. And if we plot the position versus time graph, then we would see the slope getting steeper, indicating that it's getting faster. So this is exactly like the accelerating car. This next picture is the exact same analysis, but instead of a position versus time graph, I've chosen to allow Logger Pro to plot the velocity along the ramp against time. And what you'll notice is that the velocity versus time increases with a constant linear slope. So we've seen this before, and so our next task will be to analyze the slope of a velocity versus time graph as well as the intercept.